Hello students, let us study addition of fraction. I will be explaining you the example from my practice time 3, page number 65. Add the following fractions. These are your normal fractions. So I will explain you the first example, that is the B1, where you have the denominators same. We have learned in the earlier classes, when I have the denominators equal, what I do is I keep the denominators same once in my answer and only the numerator numbers are added. So as you all can see, I have added 3 plus 4 upon 5. 3 plus 4 upon 5 gives me 7 upon 5. Now finally, when I could see that the answer that I get is an improper fraction, I have to further convert it into mixed fraction. The very first step you have to do after seeing the answer is check if it can be reduced. If it cannot be reduced, then you have to convert it to mixed fraction. This was example number B from your My Practice Time 3, page number 65. Now I'll explain you example number D. 2 upon 9 plus 1 upon 10. As you all can see, here my denominators are different. So I need to take the LCM of the denominator digits. The major misconception that children have is sometimes they take the LCM of the numerators. No children, we have to always deal with the LCM of the denominator digits. Here my denominators are 9 and 10. So first I take the LCM of 9 and 10. As you all can see, I get the LCM as 90. Now my next step is to convert this 9 as 90 and this 10 as 90. So which is a number which will give me 90 after multiplying it by 9? 10. Exactly. So this is what I have done here. Whatever I do to the numerator, I do the same to the whichever number is multiplied to the denominator, the same number is multiplied to the numerator. As we all know that though it is a fraction, it is numerator and denominator, this is considered to be 1. So when I do 9 multiplied by 10, I have to multiply 10 with the numerator as well. So 2 multiplied by 10, 9 multiplied by 10. Similarly, I have to make 10 as 90. So when I multiply 10 by 9, I get it as 90. So whatever I do or whichever number I multiply to the denominator, the same number will be multiplied to the numerator. So 1 multiplied by 9 upon 10 multiplied by 9. So this gives me 20 upon 90, that I have written it over here. And this gives me 9 upon 90, this I have written over here. So our main aim when my denominators are not same is to make them same, and to make them same we need to find the LCM. So now in this step I could see that both of my denominator have become equal. Now I write it once and I will only add up the numerator, that will give me 20 plus 9. So 20 plus 9 gives me 29 upon 90. Now children, in this case I can see that my fraction is a proper fraction. So the very first thing, it will not be converted into a mixed fraction. Second thing, check if it can be reduced. I don't think it can be reduced. So I have left up my answer in this way only. So the answer for 2 upon 9 plus 1 upon 10 is 29 upon 90. Now I continue children. I have taken the O sum to explain you. The fractions were 7 upon 8 plus 3 upon 4. Again I could see that my denominators are not equal. So I will make it equal by removing the LCM. So I have removed the LCM, I get the LCM as 8. Now since first fraction LCM is already 8, what will I do is, I am going to keep it as it is. So the digit or the number that will give me 8 by multiplying by 8 is itself as 1. So I will multiply 7 upon 8 fraction by 1 as 8 multiplied by 1, 7 multiplied by 1 will give me 7 upon 8. Then the second fraction, that is 3 upon 4, which is a number which will give me 8 after multiplying by 4, that is 2. So I multiply the numerator and denominator by 2. I get the number and the new fraction as 6 upon 8. Now I can observe that 7 upon 8 and 6 upon 8, here my fraction denominators have become equal. Now it is easy for me to add, so I'll keep the denominators one time and I will simply add up the numerators, that is 7 plus 6. 7 plus 6 gives me 13. So 13 upon 8. Here first thing I can see that my fraction cannot be reduced. Second thing, I can see that this fraction is an improper fraction and I have to convert it to a mixed fraction. So when I convert 13 upon 8 into a mixed fraction, I get it as 1/5/8. Okay children, now we continue with addition of fractions. Now I will be explaining you the sum from my practice time for page number 67. Here we are going to, I am going to show you addition of mixed fraction by method 1. Now let us see what is method 1. Now as we know children, mixed fraction is a combination of a whole number and a proper fraction. So the very first thing you are going to do here is you are going to add up the whole numbers. Here the whole number for fraction number 1, mixed fraction number 1 is 5 and the whole number for mixed fraction number 2 is 2. So just simply add 5 and 2. So I get 5 plus 2 as 7. So adding the whole numbers, 5 plus 2, I get 7. Now we will only deal with the fractional part. Now the fractional part remaining here is 1 upon 9 and the fractional part remaining here is 1 upon 8. So I will be adding the fractional part now. So adding fraction 1 upon 9 plus 1 upon 8 after finding LCM. Now I have already found the LCM for 9 and 8 children. So the LCM for 9 and 8 is 72. Now I have to make the denominators same. 9 and 8 I have to convert it in the number 72. Now 9 when multiplied by 8 will give me 72 and 8 when multiplied by 9 will give me 72. So the fraction number 1 upon 9 is multiplied by 8. So I got the answer as 8 upon 72. 1 upon 8 is multiplied by 9. Now I have got the answer as 9 upon 72. As you all can see, now here in both the terms I have made my denominators equal. Now what is my next step children? Yes, correct. Now I'll be adding these two numbers, these two fractions, 8 upon 72 plus 9 upon 72. My denominators have become equal. I'll write it only once. I'll simply add the numerators. 8 plus 9 will give me 17. Now I could observe that I cannot reduce my Can I reduce my fraction? No, I cannot reduce it. So I will keep it as it is. I can't even change it to a mixed fraction because it is a proper fraction. The answer that I have got is a proper fraction. Now what we will do is, now the whole number ka answer, that is answer number 1. Let us say that the whole numbers that we added be answer number 1 and the fractional numbers that we are added be answer number 2. Now when we add answer number 1 and answer number 2, combine it and write it together. So it will look like 7 plus 17 upon 72. Combine it, I'll get 17 upon 72. This is method number 1 children, where you have to first add up the whole numbers and then you have to add up the fractional numbers. Now I'll explain you the F1 from my practice time 4, question number 1, method number 1, where I'll be first adding the whole numbers and then I'll be adding the fractional numbers. So when I add up the whole numbers, 7 and 9, I get 16. When I add up the fractional numbers, I can see that the denominators are different. I need to make it same by finding the LCM. The LCM is 4. So the first fraction will give me the denominator 4 when I multiply it by 2. So half into 2 into 2 will give me 2 upon 4, and since the second fraction's denominator is already 4, I will simply multiply it by 1. So I'll get it 1 upon 4 as it is. Now I will add up 2 upon 4 and 1 upon 4. I could see that my denominators have become equal. So my answer becomes 3 upon 4. Now as I told you, let us say that the addition of whole numbers be answer number 1 and additional of fractional numbers be answer number 2. Now combine answer number 1 and answer number 2. I get it as 16 3/4. I hope you have understood children. Okay children, so now I explain you addition of fraction by method 2. Now let us see what is method 2. I have taken it from my practice time 4, question number 2, using method 2. I'll be explaining you the B1. Now using method 2 means children, we are adding the mixed fraction, right? So very first thing, we all know how to convert a mixed fraction into an improper fraction. That's it. This is what your method 2. Very first thing, whenever you see a mixed fraction in your method 2, you will first convert it into improper fraction. So the first mixed fraction when converted into improper fraction gives me 10 upon 3, and the second one gives me 9 upon 5. Now you will be carrying forward the same way or the same method of addition that we have done earlier. If the denominators are not equal, I'll make it equal by first finding the LCM. So now when I get the LCM for 3 and 5, that is 15, I'll convert the first fraction's denominator into 15 by multiplying the first fraction with 5. So 10 upon 3 into 5 will give me 50 upon 15, and the second fraction will be multiplied by 3. So 9 upon 5 multiplied by 3 will give me 27 upon 15. Now I can see that both of my answers, I have got the denominators equal, 50 upon 15 plus 27 upon 15. I keep the denominators digit as it is. I simply add up the numerators. When I add up the numerator, I get it as 77 upon 15. Now when I observe, it gives me an improper fraction which cannot be reduced. But definitely every improper fraction can be converted back into a mixed fraction. So here I have again converted improper fraction, that is 77 upon 15, which was your answer, again forward converted into 2 upon 15. Now I'll show you one more example, children. That is the J1. I would like to show you the J example. Again, this is a mixed fraction. I first converted into an improper fraction. I get 25 upon 6 and 7 upon 2. Now I could see that the LCM for 6 and 2 is 6. So the first fraction simply multiplied by 1 to get the same one. Second one, to make 2 6, I need to multiply it by 3. So I have multiplied it by 3. I get 21 upon 6. Now 25 upon 6 plus 21 upon 6, I got the LCM denominator. I have got the denominator same as 6. So I put it down as it is only once. I will add up only the numerator, 25 plus 21. 25 plus 21 gives me 46 upon 6. Now children, I could see that 46 upon 6 can be reduced. The very common factor that can reduce 46 and 6 is 2. So when I reduce it, this will give me 23 upon 3. But again, 23 upon 3 cannot be further reduced. So this gives me an improper fraction which can be converted into a mixed fraction, and the answer is 7 2 by 3. Okay children, now let us study subtraction of fractions. I'll be explaining you the example from my practice time 5. Subtract the following. It is same like addition, children. Only the thing is, instead of addition we do subtraction. The first example with same denominators, take it once. 4, this time instead of add I'll do subtract. So 4 minus 1 gives me 3 and 5 down as it is. So the answer is 3 upon 5. Now I'll explain you a sum where I need to find the LCM. So the E1 I'll be explaining you with subtraction. This is 9 upon 12 minus 2 upon 4. The LCM for 12 and 4 is 12. So the first fraction has the denominator itself as 12. So I'll simply multiply it by 1. The second fraction I have to make the denominator as 12. So when will I get 12? By multiplying it by 3. So 2 upon 4 is multiplied by 3 and I have got 6 upon 12. Now I write these fractions together with a subtraction sign. After conversion of the LCM number in the denominator, I get 9 upon 12 minus 6 upon 12. As the denominators have become equal, I will write it once, and 9 minus 6 gives me 3. Now children, observe 3 upon 12. Can it be reduced? Yes. 3 is a common factor which can reduce this fraction. So 3 1s are 3 and 3 4s are 12. So the fraction becomes 1 upon 4. I'll explain you one more example, children, from the same my practice time 5. I'm explaining you the K1, children, from my practice time 5. subtraction of fractions. So I have the fraction 4 upon 7 and 3 upon 6. The LCM, as you can see, the denominators are not same, so I will find the LCM. The LCM is 42. Now I have to make the first fraction 4 upon 7's denominator as 42. So 6 is a number which when multiplied will give me 42. So I need to multiply 6 by both numerator and denominator. I get 24 upon 42. Now the second fraction 3 upon 6. When I multiply 6 by 7, I get 42. So the full fraction will be multiplied by 7. So it gives me 42, 21 upon 42. Now I write down the answers. 24 upon 42 minus 21 upon 42. The denominators are same, so I will write it once. What I'll do is I'll simply subtract the numerator. 24 minus 21 gives me 3. Again observe children, 3 and 42 can be reduced. The common factor is 3 itself. So 3 ones are 3 and 3 14s will give me 42. So the answer for 4 upon 7 minus 3 upon 6 is 1 upon 14. Now children, we will learn subtraction of mixed fraction. I'll be explaining you the example from my practice time 6, C1. You can see that I have two mixed fraction. Please note children, as like for addition of fraction, we do not have two methods for subtraction of fraction. We will be taking only one method, that is the second method, by converting the mixed fraction into an improper fraction. Now first I convert both the mixed fraction into improper fraction. I get the answer as 41 upon 8 minus 17 upon 7. The LCM for 8 and 7 gives me 56. Now I have to convert the first fraction's denominator as 56 by multiplying the fraction with 7. I get 287 upon 56. The second fraction I need to multiply by 8 to get the denominator as 56. So second fraction 17 upon 7 multiplied by 8 will give me 136 upon 56. Now I subtract the answers that I have got with denominators as 56. 287 upon 56 minus 136 upon 56. So 56 will be written only once because they have become equal. I subtract 287 minus 136, I get 151 upon 56. So here children, these numbers cannot be reduced by any common factor, so I simply convert it into a mixed fraction. I get the answer as 239 upon 56. Okay children, I continue with subtraction of mixed fraction E1. The number is 10 1 by 3 minus 7 4 by 6. Convert it into improper fraction. I get 31 upon 3 and 46 upon 6. The LCM for these two fractions is 6. The first fraction to be converted with denominator as 6, I multiply by 2. I get 62 upon 6. The second one to be multiplied by 1 itself because the denominator is already 6. So I get 46 upon 6 itself. Now subtract 62 upon 6 and 46 upon 6 because now I have made my denominators equal. So 62 minus 46 will give me 16 upon 6. If I observe, 2 is the common factor which can reduce both of my numerator and denominator. Please note children, reducing of fraction is common for proper as well as improper fraction. Even if you get a proper fraction as the answer or improper fraction as the answer, first you have to check whether it can be reduced. So I can reduce it by 2, 2 3s are 6 and 2 8s are 16. Now I cannot further reduce, but still my answer is an improper fraction and it can be converted now into a mixed fraction. So it becomes as 2 by 3. To continue with the G1, my mixed fraction were 8 1 upon 4 and 1 3 upon 12. Converting into improper fraction, I get 33 by 4 minus 15 by 12. The LCM is 12. So 33 upon 4 to be multiplied by 3, I get 99 upon 12. For the second fraction, the denominator is 12 itself. So simply multiplied by 1, I get 15 upon 12. So 99 upon 12 minus 15 upon 12. Now I simply subtract the numerators because my denominators have become equal. So I write it only once and 99 minus 15 gives me 84. Now I can easily reduce it because 84 is a multiple of 12. So 12 ones are 12 and 12 sevens are 84. I get the answer as 7 upon 1. Now children, please note in this sum, whenever you have 1 as the denominator, the fraction is considered to be a whole. So here this fraction is not an improper fraction. This fraction is a makes the answer as a whole. So 7 is a single digit which is a whole number and the answer is 7.